Alright, so in this video what we'll be looking at is z-scores and probability, and we're going to start with a real simple question. If we can assume a normal distribution, what's the probability of randomly sampling a z-score greater than or less than 0.75? Now, to help yourself out, one of the first things you should do is draw a sketch of the distribution and fill in the values you know. For example, we know that the mean of a z-score distribution is 0, and 0.75 should fall to the right of that. Now, the two requisite areas of that distribution are now the tail to the right of our score of interest and the body to the left of our score of interest, based on whether they have the lion's share of the distribution or not. Now, most statistical textbooks have a table that looks something like the one I'm writing out here. And I'm only writing out 3 rows of said table, but it'll tell you a z-score and the proportion of the distribution that's in the body or tail, respectively. So for this problem, all we really have to do is look up 0.75 in said table, and then we can say, okay, there's 0.7734 in the body, 0.226 in the tail. So when we want to say what is the probability of getting a z-score greater than 0.75, it's the area right of our score, 0.226, that area in the tail, and the area in the body for less than 0.75, the area in the body. So let's think about a more complex question. Let's say we're dealing with a distribution x that's normal, has a mean of 75, and a standard deviation of 5. If we were to randomly sample one score, what is the probability of that score being less than 68? So we can't go direct. We need to convert all our scores to z-scores. But first, draw that sketch. It helps. So we know 75 is the mean, 68 is our raw score, and we need the area to the left of that, which in this case is going to be the tail. What we need to do is find the z-score that corresponds to our raw score. What we should first do is write out that formula, which is going to be x minus the mean divided by the standard deviation. So we substitute in those values. X is 68, the mean is 75, and our standard deviation is 5. 68 minus 75 is negative 7, divided by 5 gets us negative 1.4. Now I'm just going to append to this table I wrote out earlier. Now, one thing you'll know is that most statistical textbooks do not have negative numbers in their unit normal table in the back of the book. Rather, they only have positive numbers. But if it's normally distributed, it's symmetrical, and you can just look up 1.40 and then do the math in your head to essentially mentally flip it. So we look up 1.40, and we know from our sketch we need the area in the tail, which is 0.0808. And there we have that probability, about 8% or so.